the topic of evaluating functions. So make sure you have this title, Evaluating Functions, in your notes, along with today's date. And our target today is I can evaluate functions numerically. In parentheses is just a reminder to you that functions may be represented in multiple ways. They could be on a graph, they could be in a table, it could be a list of ordered pairs, it could look like an equation, which we would put in function notation. On this slide, just reminding you that f of x equals y. So y is the output, and x is the input. You'll notice on A, I used F to name my function, but on B, I used H, and on C, I used G. You can use any letter to name your function. What I want to show you is that you can use these function rules, A, B, and C, and come up with points that you could plot on a graph. So on A, the input is -1, and the output is 1. If I put that on a graph, I would go to -1 and then up to 1 and plot a point, and this is A. On B, the input is 2 and the output is 7. I would go over to 2 on the x-axis and up to 7. 1, 2, 3, 4, 5, 6, 7. I have to go off my graph a little bit. And this is where I would put point B. On the third one, my input is 1 and my output is -1. To put this on the graph, I would go to 1 on x. You always go to x first, and then -1 on y. And this would plot point C. So what I have is a list of ordered pairs, which is right here, list of ordered pairs. And this list of ordered pairs has been made into a graph. So those are two representations that you could have of a function. And I could even take that list of ordered pairs and make it into a table with my inputs under X and my outputs. You'll notice that these are just direct relationships from the ordered pairs that we just had. So this is 3 ways. You can have a list of ordered pairs, you can have a table, you can have a graph. Those are 3 ways you can represent. And the original way that A, B, and C were given as function rules. Those are also ways to represent functions. On this page, we're just going to do a lot of practice from a table. So on A, they're asking me to find f of -3. I'm going to use this table to find f of -3. F of -3 is actually showing me that I'm going to be using this input -3, which is actually x. So I'm going to go along the x, and I'm going to look for -3, and here it is. Here's where -3 is. That means my output is actually 2, right underneath it for the f of x. On B, I'm going to do the same thing, f of 20, so 20 is actually x. I'm going across the x part of my table to where 20 is. 20 is at the end, and the output for 20 is 0. Now, find f of 8. That means x is 8. So I'm going across to where x is 8, and my output is 4. And on D, find f of 0. Once again, they're giving me x is 0, so I'm going to go where x is 0, and my output is -1. Now questions E, F, G, H are the opposite. On E, F, G, H, they have given me that f of x is 9. So I'm going to be looking at my f of x row to find 9. Not this 9, not this first 9, but this 9, the f of x 9. So this is the one I'm looking for. And the question is, what is x? X is 2 in this question. Let's try that again. For f of x equals 4, so I know f of x equals 4, not x. Don't know what x is, but f of x is 4. So I'm going to go on my f of x row, over till I find 4, which is right here. And x is 8. So let's try that again. On G, f of x is 0. So go on your f of x row and find 0 to discover what x is. When I find 0 on the f of x row, x is 20. And the last one, f of x equals -5. Here's where f of x equals -5, and the x value is 9. So you need to make sure you're paying attention whether you are given x in the parentheses, like question A, B, C, D, or if you are given the entire f of x, like questions E, F, G, H. Now you see a representation of a function already on a graph. The ordered pairs have already been plotted and they've been connected, and we have this shape that you can see on the graph. Questions A, B, and C are 3 types of questions that you could be asked from this graph. So on A, it's telling me to find f of x. That's really telling me to find y. Remember, you have an x-axis and a y-axis. And don't forget, y and f of x, or g of x, are the same thing. So we're using f of x. I'm finding y. They're giving me x is -4. So I'm going to go on the x-axis to -4, 1, -1, -2, -3, -4. So here I am on -4. And I'm looking for where that curvy line is. And that curvy line is above. So I'm going to go all the way up to that spot. This is x is -4. What does it align with on the y-axis? It's in line with 2. So it is 2. On B, asking the same kind of question in a shorter version. In this version, find f of 0. I already know that x is 0. So I'm going to come over to 0. And it's actually on 0, 0. The curved line actually goes through 0, 0. So it's 0. And C is asking the reverse question, and it might be hard to notice that. F of x is 0. So now they're asking me to go on the y-axis to 0. It's right here in the middle, and it's still at 0, 0. So x is 0. So once again, pay attention to whether you're being asked to find f of x, which is y, or just x. On this page, you see another table, but you are also given a function rule to follow for this table, and this is the function rule, f of x equals 5x minus 3. You'll notice in the first box, we are asked to find x, and we are given f of x. So what I like to do is copy the original rule. So f of x equals 5x minus 3, and then fill in what I know. What I know is that f of x is negative 13. So I can replace this with negative 13. I don't know x yet. X is the empty spot in the box. So I leave x. And then I notice I have a two-step equation that I can solve. To begin to get x alone, I'm going to plus 3 on both sides. Negative 13 plus 3 is negative 10. Bring down my 5x, and negative 3 plus 3 is 0. 5x plus 0 is still just 5x. Then I'm going to divide by 5 on both sides. Negative 10 divided by 5 is negative 2. 5 divided by 5 is 1. 1 times x is x. So x equals negative 2. Negative 2 goes here in the table. On the next part of the table, I notice that I'm given negative 1. And the negative 1 that I'm given is x. All the way over here, you can see that that is the x value. So once again, I want to copy the entire function rule that I was given. F of x equals 5x minus 3. And I'm going to replace what I know. I know that x can be replaced with negative 1. If I'm replacing x and it doesn't have parentheses, I'm going to put parentheses like I did right here. And then you may recall that this is just function notation. This is not f times negative 1. There is nothing to do with it. The only side that has something to do is the right side. 5 times negative 1 is negative 5. Bring down my minus 3. And negative 5 minus 3 is negative 8. So negative 8 is the missing f of x. Please notice when you're missing x, you can solve an equation. When you're missing f of x or y, then you just do a calculation like we did to get negative 8. Let me show you that again. On this third part of the table, I have f of x given. So once again, I'm going to copy the entire function rule. And I have negative 3 for f of x. So I get rid of the entire f of x and replace it with negative 3. But I do not have x. So I keep x. And now I have a two-step equation to solve. To begin to get this x alone, I'm going to plus 3 on both sides. Now you'll notice I usually cancel out these 3's. But on the left-hand side, I'm not going to cancel out. I'm going to actually calculate that equals 0. I draw a line if I mean to cancel it. If I didn't mean to cancel it, such as negative 3 plus 3, then I actually do the calculation, which gives me 0. I'm going to bring down my 5x, which hasn't been worked on. Then I'm going to divide by 5 on both sides. 0 divided by 5 is 0. 5 divided by 5 is 1. 1 times x is x. So in this case, x is 0. So 0 is my missing value. That's not just supposed to be a circle. That's supposed to be 0. Now, another one. On this last box, I have x. I do not have f of x. So copying the function rule again, I'm going to replace x with 1. And since this isn't really anything to do right here, the only thing I can do is the right-hand side. 5 times 1 is 5. And then 5 minus 3 is 2. So 2 is my missing value in this table. Once again, you must pay attention when you're working whether you have been given x or f of x. There are different steps to solving either way. On this problem, g of x equals 3x plus 2. If g of x equals 11, find x. So I don't know what x is. I don't know what x is. Those are the things I don't know. But I actually do know the entire g of x. G of x is 11. So I'm replacing g of x with 11, and then I'm going to recopy the rest of my function rule or my equation, and then solve it like a normal two-step problem. Subtract 2 on both sides. Divide by 3 on both sides. The question told me to find x, and that is what I ended on. I ended on what does x equal. On this problem, the name of the function is h. It says h of x is negative 2x minus 5. If h of x is negative 25, find x. That means I do not know what x equals. However, I do know that the h of x, the entire h of x, is negative 25. So I'm going to replace that with negative 25 and recopy. Then I have a two-step problem to solve. Start by adding 5 on both sides. I get negative 20 equals negative 2x. Then I'm going to divide by negative 2 on both sides, and I get positive 10 equals x. They asked me to find x. I have x. Last one of that same kind. This time the function is w. Let w of x equal 3x minus 7. If w of x equals 14, find x. Once again, I don't know what x equals, but I do know the entire w of x is 14. Then I recopy and solve. I'm going to add 7 on both sides. Then I'm going to divide by 3 on both sides. And I get x equals 7. I was told to find x, and I do have x. On this last problem, I do want to show you that you can check your work. I should be able to take the original function, w of x equals 3x minus 7, and I should be able to put 7 in the place of x and get 14. So let's see what happens. W of 7, there's nothing to do with this. This is just function notation, but there is something to do on the right side. 3 times 7 is 21, and then 21 minus 7 is 14. So this does check out when I check my work. There is always a way to check your work in math class.